Hello, everybody. Today we want to begin our journey into the world of hydrocarbons. So we're going to talk about uh, the three major family of organic compounds that are hydrocarbons. That is, to talk about the alkanes, the alkenes, and the alkynes. So when we say hydrocarbon, from the name, you can easily understand what hydrocarbon means from the name. The name says hydrocarbon, so it means they are organic compounds that are made up of hydrogen and carbons only. So hydrogen and carbon atoms only. So when you're defining hydrocarbon, you must put the word only to it, because some organic compounds also have hydrogen and carbon, but they have some other atoms with them. So because this one, they have only hydrogen and carbons, we put only there when you are defining them. So as I mentioned, we're going to focus on three major families of them, which is the alkanes, the alkenes, and then the alkynes. So these are the three families we are going to look at. When we say alkene, we're talking about those that have carbon-to-carbon single bond only. The alkenes, those with carbon-to-carbon double bonds. And then the alkynes are those, the families with carbon-to-carbon triple bonds. So let's start with the family alkane. So what are alkenes? They are the saturated hydrocarbon. The word saturated is very important. They are saturated hydrocarbons, that is, they contain only single bonds between carbon atoms. So that is why we said they are saturated. That's one reason why we said they are saturated. They contain only single bond, that is, each atom is bonded to the maximum possible number of hydrogen atoms. Each carbon atom, rather. So remember, a carbon atom has the ability to bond with 4 other atoms around it. So what makes alkane saturated is because the carbon atom there, if you look at this carbon to carbon, look at this, this is ethane. Ethane has, uh, each carbon has used one of the 4 bonds around it. So it means one has 3 bonds left, and this one has 3 bonds left. Now, if all the 3 bonds for this carbon, if they are all bonded with what? With hydrogen, and then also hydrogen, hydrogen, like this, or even not hydrogen, if they are bonded with some other atoms, but we normally use hydrogen as to define saturated. So it means this is saturated because the remaining 3 bonds are bonded with what? With hydrogen atoms. We're talking about saturated. So this carbon has 4 bonds around it, and then one is used to bond with another carbon atom. The remaining 3 bonds are bonded with hydrogen atoms. So we say each carbon atom is bonded to the maximum possible number of hydrogen atoms. That is why we say they are saturated. We also call them paraffins, if you've heard that word before. Paraffins. So they are paraffins, from the Latin parum affinis, which means little affinity. Little affinities means low reactivity. They are not so reactive. So that's why they call them paraffin. Yeah. What is their general molecular formula? Of course, it's CnH2n plus 2. That is the general molecular formula of alkanes. Now, we'll move quickly to their nomenclatures. Of course, before I go to nomenclatures, when we say general molecular formula, it means you can derive the name of any family member from this general molecular formula. For example, if I ask you, what is the chemical formula of butane? you know that butane will have 4 carbon atoms. For butane, C is equals to 4. So if C equals 4, so it means we can, 4 carbon atoms. So if there are 4 carbon atoms, so it means it's going to be C4. So it means N equals 4. So if N equals 4, multiply it by 2, add 2 to reach, we're going to have H10 here. So this is the formula of butane. You can do that for any other family member of alkene. So that's why we said they have general molecular formula CN H2N plus 2. We've talked about nomenclature before, so I will not bother you with nomenclature of alkenes. You can just look for alkene and then try and name them. So we will move further quickly to the structure of alkenes. What is the structure of alkene? Number one is, if I use this as an example, let's look at methane as an example. So this is methane. This is just the 1D structure of methane. If it is in 3D, it will appear like something like this, to look just similar to diamond. If I can draw it very well, something like this. So this is tetrahedra. So the geometry or the structure of alkane is tetrahedra. So that is, when we say tetrahedra, it means each common atom in an alkane is sp3 hybridized. That is 1 sigma bond and 3 pi bonds hybridized to give us the molecule, to give us the structure of the molecule. So, and then what about the bond angle? When we say tetrahedra, the bond angle is going to be 109.5 degree centigrade. Tetrahedra with bond angle approximately 109.5 degree. Of course, we mention it because we said they are saturated, so it means all bonds in an alkane family member will be single bonds. So bond between carbon and another carbon is going to be single bond. Bond between carbon and hydrogen, or bond between carbon or any other atom in that molecule is going to be single bond. So they contain carbon to carbon single bond only, and also carbon to hydrogen bonds. They contain single bond only. So because of that, remember when we say single bond, we are talking about what? Sigma bond. So they have strong sigma bonds. So they have strong sigma bonds because they have only single bond. What about the conformation? So although there are free rotation between carbon to carbon single bonds. So, but there are so many ways we can arrange them. I don't know whether your syllabus needs this conformation, but there is staggered conformation. Staggered conformation, which is more stable than eclipses. Okay, let's go further quickly into synthesis of alkanes. Synthesis of alkane. So we're talking about alkane. How do we synthesize them in the laboratory? So we don't generally synthesize simple alkanes in the lab for everyday use. For example, the one we use in the kitchen, that is our cooking gas, they are majorly alkanes. They are not synthesized for everyday use because they are readily available from natural sources like petroleum and natural gas. We get them readily available. However, there are some common laboratory method of synthesizing them, and then we may need them. You may need them in the exam. They may ask you. So that is why we need to talk about synthesis of alkane. So the first way of synthesizing alkane is from hydrogenation of unsaturated hydrocarbons. Hydrogenation of like alkenes or alkynes. So when you have an alkene molecule like this, so the R represents alkyl group, so or any other group that is attached to carbon. So that's why we put R there. So plus two hydrogen atoms. So we have our alkene family member reacting with hydrogen atom. So this equation, if an equation has catalyst, you need to include it in the exam. So they normally use nickel catalyst, or they can use palladium catalyst, or even platinum can be used. Any of the three can be used as the catalyst for the hydrogenation of alkene to give us alkane. So remember, I said one of the ways of making alkane is what we're talking of making alkane is what we're talking about here. Hydrogenation of unsaturated hydrocarbons. So when this one is hydrogenated, that is, we add hydrogen to this molecule. So we are going to have the double bond will be broken, and then we will have R. The R is there. CH before becomes CH2, and then the double bond becomes single bond, and then we have CH here before becomes CH2, and then we have our R prime. So if you look at this reaction, you will see that we have only single product. Later we'll talk about addition reactions. So just like this is an example of a addition reaction. So so that is the product. For example, if this is ethane, instead of R, if you have CH2, double bond CH2 plus H2, so in the presence of nickel catalyst, so we are going to have CH3, single bond CH3. Of course, you know this is ethane, and then it becomes ethane. So when we hydrogenate alkene, we are going to get alkane.